Hello everyone, and we're on question 8 now this is from paper 1 from 2022. It says a car stops at 2 sets of traffic lights. Figure 2 shows the graph of the speed of the car, v meters per second, as it travels between the 2 sets of traffic lights. The car takes t seconds to travel between the 2 sets of traffic lights. The speed of the car is modelled by the equation v is equal to 10 minus 0.4t times by ln of t add 1. Where t is less than the capital T but greater than 0. Find, according to the model, the value of t. So we can see that from the graph that at the value of t, the velocity is equal to 0. So we're going to set v equal to 0 in our equation and see what happens. So we've got v is 0, so we've got 0 equals 10 minus 0.4t times ln of t add 1. And that means that either 10 minus 0.4t is 0 or ln of t add 1 is 0. So let's do this side first. So we end up with 10 minus 0.4t is 0. So 0.4t is equal to 10. So t is 10 over 0.4, which is 25 seconds. Now that is going to be the answer for t, presumably. But let's just check, see what's happening with the other solution. So the other solution says that ln of t add 1 is 0. So when we reverse the logs, that gives us t add 1 is e to the 0. Anything to the power of 0 is 1. So that means that we've got t is equal to 1, take away 1, which is therefore 0. So that's the origin. So the value that we're after for t is 25 seconds. Okay, that's part A done for 1 mark. Oh my goodness, sorry. That seems a lot of work for 1 mark, but there you go. Now, part B, this is a really awkward rearranging. So it says, show that the maximum speed of the car occurs when t is equal to 26 over 1 plus ln t add 1 minus 1. Okay, well, we've got to differentiate in order and set equal to 0 in order to find out our maximum. Okay, so we're going to differentiate and set it equal to 0. Now, we've got a product, so we've got u times v, so we're going to use the product rule. So the derivative of 10 minus 0.4t is minus 0.4, and the derivative of ln t add 1 is 1 over t add 1. So we're going to use the product rule, which is u dash v add uv dashed, and that's going to be 0.4 times by ln t add 1 plus 10 minus 0.4 times by 1 over t. So that's everything subbed into our product rule formula. So we've now got to rearrange this rather complicated looking thing to make t the subject. So let's have a think about what can we do here. Well, I think the first thing we can do is take this over to the right hand side. So that just gives us this line here when we do that. So all that's happened here is that has gone over there. Then once we've done that, I think we can at that point times by t add 1 to get rid of that denominator. So we've times by t add 1. So far so good there. Now we can expand our brackets on the left hand side, and we're going to have t times by 0.4 ln t add 1, and then we're going to have 0.4 ln t add 1. So we're going to do that one times that one gives us this term, and that one times that one gives us that term. Okay, so we've expanded our brackets now. So far so good. Right, so let's see where are we going to go from here. So we've expanded our brackets, and where are we? So we're at this stage here. We're at this stage here. So what we're going to do is take away that 0.4 ln add 1t. Okay, take it away over to this side because that's going to enable us to. Oh, actually no. What we're going to do is add 0.4t over to that side. Sorry. So we're going to leave that where it is and add 0.4t across to the right hand side. This 0.4 ln t add 1, that one is going across to the left hand side, so it'll become minus. So all that's happened in this stage is that's moved over there and that's moved over there. Okay, so we can do some presumably factorising now. So let's see what's happening. Or in fact, yeah, we can factorise out a common factor of 0.4t from these two terms, giving us 0.4t, open brackets, ln t add 1, add 1. Okay, and then over here on the left hand side, that is equal to 10 minus 0.4 ln t add 1. Okay, so now we can just divide by 0.4, and when we divide by 0.4, 10 divided by 0.4 is 25, and 0.4 divided by 0.4 is 1. Okay, so that gives us 25 minus ln t add 1. And that is all equal to this expression, but without the 0.4. Okay, so now all we need to do is divide, well, we're still carrying on, but we divide now by that. So we've now got to this stage here, okay, and this is looking okay, except we've got 25 and we need to have 26. So what we're going to do is employ a little trick, and the trick that we're going to employ is we're going to think of 25 as 26 take away 1, because 26 take away 1 is 25, okay, so this 26 take away 1 is just another way of writing 25. So now what we can do is we can write the 26 over ln of t add 1, which is super useful. And then we've got minus this here. But this, when you take a minus 1 outside of that whole thing, take out a minus 1, turns out to be ln of, 1 add ln of t add 2. So we end up with that also dividing by 1 of ln of t add 1 as well. So from earlier in the question, that one is the same thing as well. Okay, so now what we've got here is we've now got, this is the same thing, so this is just 1. That's going to cancel, that whole thing's going to cancel and become 1. So we've now got t, and we've got 26 over that minus 1 as required. So that was a bit of a horrific thing, but we got it. Okay, the next bit. Use the iteration formula with t equals 1 to find the value of t3 to 3 decimal places. Okay, so this is the old spam equals thing. Now, obviously, it depends on what calculator you've got, but you put 7 in there, press equals, and that's it programmed into your calculator, the 7. And then we're going to have a fraction button, and we're going to have 26 over 1 plus ln of answer plus 1, close bracket. And then every time we press equals now, we're going to be going like once round that loop, okay? So actually, I forgot there to have my minus 1, so I should really reprogram it in, but we need to have the minus 1 at the end as well. Now, when you program that in the way that I was showing there, you end up with, the first one is 7.44308, and then the third one is 7.2978, so therefore T3 is 7.298 to 3 decimal places. And then it says, by repeated iteration, the time taken for the car to reach its maximum speed. Now, this is where you just keep on spamming equals. You know, you just keep on pressing equals loads and loads and loads of times, and it's going to settle down to 7.33 is the answer that you'll get when that whole thing settles down. Perfect. Okay, I hope you found that useful, and I'll see you in the next video. Remember to subscribe, to like and subscribe. That would be perfect. Thank you so much.